Hello guys, today we'll discuss all the important problems and their complexities. We've studied so many problem solving strategies starting from divide and conquer to branch and bound. In this video I will discuss all the problems discussed along with their complexity in brief. I hope this video will be beneficial for you recalling all complete ADA algorithm in 10-15 minutes. So before we start, let us first discuss the complexity series. I am just recalling that will be beneficial to you understand the comparison of complexity. So this series is always important. The lowest complexity is of constant term, then log of log n, then log n, root of log n, root of n log n square, n cube, n to the power k, 2 to the power n, and n to the power n. This series is always important. So let us start with the very first problem, that is linear search. The complexity of linear search is big O of 1 in best case. If I will recall you, it is something that the element is placed at first position, and big O of n when the element is present in the last position, or you can say is not present in the list. Let's come to binary search. Again, the best case complexity is big O of 1, that is element present in the middle of the list, and the worst case is log n, whether the element is at first position or at last position or any other position, or you can say not present in the list. Come to quicksort. The best case complexity is n log n, where we can say the list is dividing from its middle, so that the pivot is always divide the list into two equal lists. And the worst case is big O of n square, where we can say the pivot divide the list into 1 and n minus 1 elements. Now come to merge sort. Best case, worst case, average case, all cases are n log n. Now stress matrix multiplication. Before that, matrix multiplication. The complexity of matrix multiplication is n cube, as the nested of 3 for loops, all dependent on n. That's why the complexity n cube. And stress matrix multiplication, we have reduced this n cube complexity by using 7 variables and 18 addition subtraction, 7 multiplication and 18 addition subtraction to big O of n to the power 2.7 using divide and conquer strategies. Come to insertion sort. This is one of the sorting algorithm having the comparison based sorting algorithm having the complexity of the order of n. That is important. It is important. In almost sorted list, the insertion sort gives the complexity of the order of n. This is the best case insertion sort. Otherwise, the complexity is n square. Heap sort, in all cases, complexity is n log n. Bubble sort, big O of n square. Matrix multiplication I have already discussed. So up till now we have covered divide and conquer. Now move to some other complexities and with important problems. To start with greedy knapsack problem. The complexity is big O of n. Here we are considering that we have already considered the sorted sequence, that input selection criteria already input is sorted and we are selecting one. Normally greedy means selecting some out of n. That's why if the given the sorted series, the selection will be big O of n. Otherwise, you can say it will be of the order of n square. If we consider the heap, then complexity will reduce to n log n. Now job sequencing with deadline, the complexity of the order of n log n. Here also, when we consider Fibonacci kind of thing, then there will be n log n. Otherwise, it will be n square. The same with optimal binary merge pattern, big O of n square. Two important graph traversal techniques, Prim's and Kruskal. Here you can see in Prim's we talks about adjacents. Here you can see the complexity will be big O of E log V. Again here if we use Fibonacci heap, the complexity will reduce to E plus log V. In case of Kruskal, complexity will be E log V, or you can say E log E. Here in Kruskal we consider the sorted edges and select one by one from the minimum one. Now single source shortest path, the complexity will be big O of n square. or n plus e log v, again in case of Fibonacci heap or other data structures. This was all about greedy, where the logic is selecting sum out of n. Here we take in dynamic there will be overlapping of options, but here we try to explore all possibilities so that we will reach to optimal one. So 0 knapsack will have the complexity of the order of 2 to the power n. Will have the complexity of the order of n square. In multi-stage graph, the complexity will be of the order of n square. Multi-stage graph, here you can say various stages are given. We have to reach from source to destination by selecting one vertex from each stage, and the objective is to get a reach from source to destination at minimum cost. Reliability design, it is having the complexity of the order of 2 n. You have to design a system with n devices with different reliabilities. The total reliability will be product of each devices. We have to increase the reliability by taking devices in parallel. For this, we will consider all possibilities, and this complexity will be reached to 2 to the power n. Capital assessment problem. Here the complexity will be big O of n square into 2 to the power n. All pairs shortest path. It is, you can say, the variant of n is single source shortest path. For all pairs, for single source shortest path, complexity is n square. For all pair, say n vertices, for each one n square, the complexity will be big O of n to the power k. Now let's move to backtracking. Here in backtracking is used basically for finding all possibility. It is not used for optimization. So here you can see the most of the algorithms are having a complexity of the order of 2 to the power n. Why? With n options we have to decide whether to select one or not. That's why the complexity will be of the order of n square. So 4 cube or red cube problem, here on a chessboard of 2 cross 2 we have to place 4 cubes such that no 2 cubes will cross each other, or you can say they attack each other. Here it means row wise, column wise or diagonally no 2 cubes should attack each other. So here the complexity will be of the order of 2 to the power n. Sum of subset problem, the complexity will be of the order of 2 to the power n. Graph coloring, the complexity we can say of the order of 2 to the power n. Or it is something m to the power n, where m is the number of colors and n is the number of vertices. Hamiltonian problem, the complexity is of the order of n square 2 to the power n. It is similar to traveling salesman problem in terms of complexity. Now come to branch and bound. 8 or 15 puzzle. Here on the chessboard of 3 cross 3 we have to place 8 numbers in chronological order. 0 on knapsack, the same. Here branch and bound, we have some bonding function by which we will decide how to bond some of the node for exploration based on the upper or lower values. And traveling salesman problem, again the complexity will be n square 2 to the power n. What you need to do is you have to explore all these in such a way that using this video you can recall all these things. I suggest you to add few lines regarding to each of the problem, so that it will be help you in recalling all these things in a faster manner. Thank you.